to take a minute here and we're going to look at the squeeze theorem. The squeeze theorem is used very infrequently to evaluate limits. It's got some really specific things that have to happen. Basically, we've got one function here, this blue function, which is always above this orange function that's down here. And what the squeeze theorem says is if we have some third function that's always between those two, doesn't matter what it's doing, that at this point here where that blue function, the orange function meet, the limit of this middle function is going to be the same thing as the limit where those two meet. Which makes sense, because if there's these two functions and they're converging onto a certain point, there's another function that's always between there, well then yeah, that third function has to have that same limit. So we're going to look at an example really quickly here. We're given that f of x is less than g of x is less than h of x at all values. We have if the limit as x approaches c of f of x is 5, and the limit as x approaches c of h of x is 5, find the limit as x approaches c of g of x. So this represents our smaller function, and this is our larger function. And we're going to look at g of x, which is between them. So we can take this thing right here, this f of x is less than or equal to g of x is less than or equal to h of x, and we're just going to rewrite it with using the limit as x approaches c in front of each one of these. So the limit as x approaches c of f of x is then going to be less than or equal to the limit as x approaches c of g of x is going to be less than or equal to the limit as x approaches c of h of x. And these two things we know. We're told the limit as x approaches c of f of x is 5, and we're told the limit as x approaches c of h of x is also 5. So if we fill these two things in our inequality here, we get that 5 is less than or equal to the limit as x approaches c of g of x is less than or equal to 5. So, we know from inequalities that what that means is that the limit as x approaches c of g of x has to live between or equal to 5 and 5. And the only value here that makes this inequality work is 5. So we can say that this right here is 5. So the limit as x approaches c of g of x equals 5.